So, hi everyone, can you hear me? So, I think it's best time to start today's section. So, I'm gonna be starting today's section now. So, with a quick recap on what we have done, I hope you can hear me. I don't know if, let me check that my microphone is on. Can you hear me? Okay. I think my microphone is on. Okay, so in the last section, we talk about pods, we talk about replica sets, then deployments, we talk about service. So that's how we wrap up our last section. So today I will be going and talking about namespaces. So just a quick recap of what we did. We talk about service, where we talk about the cluster IP, the node ports, we talk about the load balancers, then we talk about the DNS. And remember, we said in the DNS we use core DNS in this, so we'll talk about that in our last section. So this is the part 3 of Kubernetes Weekend, and now we'll be starting with namespaces. So if you, in our first section, we just talk a bit about namespaces when we are trying to create pods, and there are a lot of questions arising like what's namespaces, how is this and that. Yeah, we're going to dive deep into what is namespaces and why is it very important. Now, namespace is one of the most important concepts when it comes to Kubernetes and even when it comes to Openshift. So mostly in Openshift, namespace is called projects. So you can be hearing about projects, like creating projects. It's the same thing as creating namespace. So in Kubernetes, we call it namespace. So if you use namespace, is also very common in Openshift. You can use anyone, just like just a name that you can use interchangeably. So when it comes to Openshift, but when it comes to Kubernetes, we call it namespaces. So now, what is namespaces? Namespace. Now let's come back from the English word namespace. That means you are giving your name a space, like just want to explain it in a term that we can relate to and understand. So we said namespace. So it means like I have a name, then I want to create a space for myself, just like that. So it means like if I have my own, okay, let's look at it in this way. Take, for example, a country like Nigeria. Nigeria is a name. Then Nigeria now occupy some space. Let's say in Africa. So let's look at it, Africa as a Kubernetes. Okay, let's look at Africa is like a cluster. I'm just trying to explain so you can relate to it, what this concept is all about and why is it used. So I just want to understand the concept. So let's say Africa is a cluster. So if Africa is a cluster, then, okay, I want to find a better way in which okay, let's just look at it in that way. And in all our cluster, let's assume we have our nodes set up like that. And then let's now take Nigeria, for example. Let's take it as if it's a namespace. Let's take it in that way. I'm just trying to draft something in my head to explain this concept so we can get it. So let's say it's a namespace. Then it's now occupying a place in the south, in the west, in Africa. So it's occupying a particular space in that West Africa. It has its own boundary. So when it has its own boundary like that, It has its size, it has its dimension in it. So we call it Nigeria, for example. So everybody that is in Nigeria, we call them Nigerians. They are the one that live in Nigeria. But at the same time, okay, let's just use the word West Africa, for example. Let me just limit it. So they can go to other West African countries. They are still Nigerians though, but they can easily move to other West African countries because of the AU, like African Union. So they can easily move without go and apply for visa and that. But what I'm trying to say, Nigeria is a place, is a name, it has its own namespace. So everybody in Nigeria, we can easily relate to ourselves based on our language. It's very easy to understand what we are saying, and we are in that country. So let's take, for example, another country, let's say Ghana. Ghana too has its own name, has its own what? Has its own its own size, and the people living inside, we call them Ghanaian. So if I'm in Nigeria now, in Nigeria, I don't need to identify myself as a Nigerian because I'm inside Nigeria. So you know that what I'm in Nigeria, we can relate to ourselves. So I don't need to be said, oh, I'm Nigerian. You already know that I'm Nigerian because I'm inside the namespace. Take for example, I'm now in Ghana. Though I'm still in that, I'm still in West Africa. But if you want to refer to me, you just say, okay, this guy is a Nigerian, right? So what are you trying to do? You are still referring me back to the name of my country. So now that's a similar concept when it comes to namespaces. So like say in Nigeria, let's assume that is a namespace. So inside that Nigeria, we have everything we want, like everything, everything that makes the country organized is in Nigeria. Everything is in Ghana. Let's say, for example, another region, let's say in the south, like South Africa too. So let's take each country like that as a namespace. So everything that happens in Nigeria is within the walls of Nigeria. If I want to, okay, let me pause with that concept. I don't know if you understand that concept, but just chill. Maybe when I explain further, you understand what I'm saying. Now, if you should look at what is on my screen now, if you should look at this yellow color, we call it a namespace dev. Then this blue, we call it namespace staging. Then this is namespace production. So this is the namespace. This dev is just the name, just like country. We have Nigeria, the name of the country is Nigeria, but it has its own, is a country. The same thing like this. So the name of that namespace is staging. This one too. Let's say the namespace is production or namespace dev. Anyone, just let's use this dev, staging, and production. So everything in this yellow is just like a closed system. It has its own pod. Let's say it has pod A, pod B, can have as many pod as we have, let's say. So this pod has a service that exposes this pod to be able to communicate. The last time we talked about service, that service is the line of communication within the pods and outside the pods, or within the node and outside the node when we talk about cluster IP, communication within the cluster, within the node. Then we talk about the third one, we talk what's it called? Node pod, cluster pod. We talk about load balancer and DNS. Remember, we just talked about that. So I'm just taking that, just rewinding so you'll be able to understand what I'm saying. Now, inside this dev, it has its pod, it has its service. So everything that happens is just like a closed system, just like an house in which everything in that place can communicate with themselves. Just like in Nigeria, everyone in Nigeria, we can communicate with ourselves. I can easily say, okay, this is this person from so state. I can easily, okay, this is your state. I can move to any state without applying to anything or any restriction. I can just wake up, take a bus, go within Nigeria. So now the same thing happens in Ghana too. Let's assume this one too is in Ghana. They can do anything they want within that country. Let's say this place also is like South Africa. So, but for me to travel from Nigeria to Ghana, I must have my passport, my Nigerian passport. That shows by what? My country's name, which is like say the namespace name. So the same thing, someone in Ghana wants to come to Nigeria, you must have the passport. You can't just, for you to go outside of Ghana, you must have your passport, which will show that you're a Ghanaian. It's going to show Ghanaian passport, Nigerian passport. Let's say this one is South Africa, South African passport. So, but inside Nigeria, I don't need a passport to go to what? To go to, let's say, Ogun State, Lagos State, Abuja, Port Harcourt, any other state. I don't need anything. I can just go within there because I'm what? Within Nigeria. So that's what exactly happens in namespaces. Now, let's go back to something. Let me demonstrate something for us here. So now when we are talking about Kubernetes too, we have namespaces. So namespaces is just like a closed section, a system in the cluster in which you can like hibernate your, not like I want to because hibernate. Like you can enclose your project or what you are doing inside that namespace, and you can have as many namespaces as possible. So if you want to create a whole project, you can put it inside one namespace, another project inside one namespace. So one of the advantages is going to make it organized, and you will know what you are doing, and like more like organization. You know, when you start creating your application and you have several pods, maybe you are in a shopping, you have a shopping, you know, let's say a shopping website, for example, and you put all the stores for shoe in one namespace. You know, when it comes to shoe, you have female shoe, you have male shoe, you have child shoe, you have adult shoe, you have different range shoe, different size. So you don't want the pods you are creating to be, you know, we might create many pods, so you don't want them to be what? To be too cumbersome that you can't really redirect here and you can't really go back and organize your whole cluster. So in that way, you can just create a namespace. This namespace is for shoe, this namespace for clothes, this namespace is for other thing. So from there, you get organized. So you know how to what? Organize your cluster. So everything you are doing is well organized. So now, I hope you can see my screen. So now, we are in our, remember we are using our, what's it called? Our Docker desktop contest. And please, I want to be sure if you can see my screen. Can someone just let me know? Hello, are we there?
Yes, yes. Yes, I can see your screen, yes.
Okay. So now, remember we are still using let's just config get contests. So yeah, we are using Docker desktop contest. So that's the contest we are using. So now let's do get namespace. So you can decide to write it in full, or you can just do get namespace. Remember the reason why we are using K? Remember in the last section we talked about the alias. So I put K into the, sorry, I've put K to be kubectl here. That's why I'm not repeating kubectl. I'm just using K just for those maybe joining us and don't understand why we are using K. So now when I do get, it's the same thing. This is the short form. So now when we are using get namespace, we can see it shows us different namespace we have. We have default, dev, development, first, this, and this. We have Shegun. I think we just created this the other time. So now let's try and get the ports we have. Okay, get ports. These are all the ports that we have. But this port that is showing for us is in our default namespace, because when you create a Kubernetes, it's going to create a default namespace for us. Like you have a default namespace that this is like You know, when you talk about websites, you say we have a landing page. So whenever you go to the website, that's where it's going to take you to landing page, like the default page. So it's something like that. So that is where we create all these pods in our previous section. Remember that these are all the pods we can see. So let's do, I want to do something. Okay, wait. So now let's, we have all these namespace. So now let's do get pods. Oh, sorry. Oh, okay. Sorry, I typed it too right. So what I did is get pods all. I'm getting all the pods inside what? The whole cluster. Give me all the pods in the whole cluster. Now, when I do get pods, this is all. I can also use get pods all. Is that, can't I use that? Let me see.
I think it's double.
Oh, sorry, yeah. Sorry, yeah, double dash, thank you. Okay, let me just get pods up. So what is all? I use A most of the time, but I think there's another one we can use. Let me confirm. Okay, yeah, all namespaces. Get pods dash all namespaces. So it's still the same thing. So you can use dash A or dash all namespaces, anyone that you want to use. So now, when I do dash all namespaces, you can see it shows all the pods that are created that is running in that cluster. Now look at this. These are default, right? Because the namespaces there is default. Now, when you go to this development, we have just one pod in it. In first, you have two. And in Kube system, we have all this. And in Shegun, we just have this. So, but when we do get pod, it's showing only the one in default for us. So that means each of these namespaces is just like an house. That's what? That houses our pods and our service. And at the same time, it houses maybe our secret, our config map. If you remember in our last section, I used something, get API resources. Oh, get, I think, okay. Okay, just a moment. I want to be sure, just a moment. Is it not API resources? I'm trying to check the history of the command that we use. Okay. 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 Yeah. Escape resources. Just a moment. Okay, so not K. What's that? What number is that? Okay. I didn't read but that's not. Let me just go down. K group API resources. So now remember that when we are checking these API resources, I was talking about this namespace here, this column. When I was talking that there are different API resources that they are what's it called, namespace based and not namespace based. So if you should look at this binding, like it works in the namespace, but this one, you don't necessarily have to create it in a particular namespace before you can use it. Like all these one, events, namespace. So you don't need to create a namespace in a namespace. So, okay, like persist, okay, yeah, this is what I want to. So because we'll be going here now, we'll be going to persistent volume very soon. So if you create a persistent volume, you can see that when you create a persistent volume, the namespace here is false. We're going together, I just want to explain. So whenever you create a persistent volume, you don't really need to create it and put it in a particular namespace. The whole is just to create a persistent volume in the whole of the cluster. And when you want to use the persistent volume, you just bind it. Maybe if you are in a particular namespace, you can bind to this persistent volume outside of the namespaces. I don't know if you understand, but just maybe when we get there, you understand what I'm saying. So these ones, if you look at all these API resources, you see that this API service is not namespace based. Like you don't necessarily have to create it in a particular namespace, like creating each, like for this persistence volume, I don't have to be create persistent volume in each namespace. You just create one in your cluster, and each of the namespace you can bind to that persistent volume. So when you get to persistent volume, you understand. So if you want to create a secret, if you create a secret is what is namespace based. So if you create a particular secret in a namespace, if you create it in particular namespace, you will use it within that namespace. If you create it within another namespace, you use it another name, you use that namespace. But if you create service account also is namespace based, you can create this particular namespace. Which like okay, there is one. Okay, so that's what just want to use that one to this API service to explain. So namespace, like I explained earlier, it's just like taking countries, for example, and what happened in that country. You can easily move. You can, or let's use another example, maybe in a house. If my own house, my son name is Adesanya. Every member of my family can call me my first name, which is Shegun. You don't need to call Shegun Adesanya before you can identify me in our home. I can just call Shegun in our house. But may I assume there's another family, maybe Adebayo, and they have someone else called Shegun. Inside the Adebayo family, they can call Shegun. They know that, okay, Shegun Adebayo, because they're inside that family. But if I want to call Shegun in that family, for my own family, I will say Shegun Adebayo. Just what to identify this, I will say Shegun Adebayo. Why? Because I'm moving outside of my namespace to identify another thing. So I must have to call it by the first name and the last name. I don't know if you understand what I'm saying. So now, where is this applicable? It's applicable when you are relating to service. Now, let's go back to service. Let's try and get the service we use, get service. So these are the service we created initially. Remember, this one are in the default namespace. And if you check up and look at service are what? Namespace bound. It is true. You can create it within a particular namespace. So let's try and get service in another namespace. Let's say Kube system. You see that it's different. Let's try and get it in Shegun namespace. It's no service form because we didn't create any service. So you can see that the service is what? It's namespace bound. So that's the principle of what? Of namespace. And how do we create namespace? So if you want to create a namespace, so let's create a namespace for week. Let's say part 3 now. So like this section, and everything we want to create now will be in that namespace. Let's say get namespace. These are the namespace where I want to create a namespace. So if you don't know how to, so to create it, you say create ns, then we give it the name. Let's say part 3 namespace created. Get namespace. You can see 6 seconds ago we have the namespace. If you have any question, you can just bring it up. So part 3. So now, if you want to create this and you don't know, create nx help. So you can get help here on how to create it. You see, okay, create namespace, my namespace. Then you can, maybe you want to use any, or maybe let's do something like this. You want to add something, okay, create, you can use as a daemon, name create namespace, sorry, namespace, let's say Femi, daemon. In a YAML file, you want to create a template. Remember, if you want to create a template for it. So this is the template to create our namespace. You see, it's telling us this is the API version. And if you remember here, namespace, where's the namespace? Namespace, this is the API version. You see, this is the kind namespace. So you see, this is the API version, this is the kind, these are metadata. So now, remember, I always tell you, documentation is our, Kubernetes documentation is always our friend. Let's see, namespace is here too. So namespaces. So if you should look at namespaces, so you can see so if you want to get pods in namespaces, like get pods in these namespaces inside the namespaces, and you can switch between namespaces like kubeconfig set context, then change it to the namespaces that you want to use. So I want to see the definition file. Okay, so like this one, if you want to know that if you want to see the what's it called, the Kubernetes resources, just like we did earlier, that are not that are not namespace bound, you can use this command just like we did earlier. So I want to confirm, am I recording? Is this display that I'm recording? Let me confirm. Okay, I think from my side it's recording.
It's recording, it's recording.
Okay, so just like what we did earlier, let me go back to it. KPI namespace equals to true. We see all the one that have all the namespaces. All these one have namespace true. Let me confirm something here. Yeah, API resources namespace true and false. Yeah, it's not in the namespace. I was expecting us to just give us a list of what is not in the namespace. Let's do false. Okay. Okay. So that's the document. Just go to the documentation, and that's it. Mainly about namespace. So let's just try and create a pod in our namespace, just like we did earlier, and expose it. We know we have already created a namespace. Okay, get. So let's just create an nginx pod in the namespace. Let's just say run image nginx. So now namespace equals to, oh sorry, what's our namespace? Part 4, right? Part 3, I think. Part 3. What else? Let's just do this. So let's give it a name. Run. Let's do part. Let's make it part 3. That's the name of the pod in this. So let's do a dry run and see what the template of what we're going to generate. Dry run in a YAML file. So this is the pod that's going to create for us. You can see this is the namespace. This is the name of our pod. This is the label it pulls in it. So we might redirect it to a new file and create it like that. And we might just remove the dry run and create it. Okay, get pods. We won't see anything because we're in default namespace. So, but we should do namespace part 3. Oh, sorry, NX. So if you want to do it in Openshift, that's the command we will use. You see, adding me, I'm in Openshift command. I will do OC get ports in namespace. Sorry, in namespace. I'll just put it the namespace maybe part 3. So this is when you want, maybe we want to be on Openshift. So this is how I'm going to get this in Openshift. So, but we are not in Openshift now, we are in Kubernetes. Let's see. Let's watch till our container is creating. So I think everything is created, is running. So these are ports that's in it. So someone asked the question that how is Kubernetes different from Openshift? So like in the first part, we didn't talk about it extensively, but I just mentioned like Openshift is just another flavor of Kubernetes. Just like, for example, if you're in Nigeria, so you can relate to it. You know, we have something we call VideoMic. So VideoMic then, like maybe 2-3 years ago, it's like, let's say 100 Naira. So there's another flavor we call the chocolate, which is more like sweeter and different from the normal VideoMic. That one is like 150 Naira. So, you know, the chocolate is kind of different. It's just like another flavor that you enjoy most for those that like chocolate. That's the exact relation between Kubernetes and Openshift. So Openshift added a lot of things to Kubernetes that would make it more interesting. So I think so Openshift is managed by the Red Hat. So it's not an open platform like Kubernetes, though, although we have some that we can use, like maybe we want to use the OC in CLC and others. Maybe we're still going to go into Openshift after we finish our Kubernetes section. So just be rest assured. So let's quickly go back. So we won't spend much of that. So that's more about namespaces. I don't know if anybody has any question that you want to ask or you don't understand and want us to go through it again. Any? Okay, so let's continue. So with that, I want us to go to another topic called scheduling, taint and toleration. Then we move to daemon sets. So we know that we're done with that. Then we now start with storage. So in that storage, that's when we're going to talk about persistent volume. We're going to talk about persistent volume claim. We talk about volume and co. So let's just quickly go over this. So I will just going to explain it in this diagram. So this diagram is kind of scattered because it's not well. Okay, so this namespace is for this. I think you understand the concept of. So let's go to what taint and toleration. Now, when we're talking about taint and toleration, is we want to, and this happens when it comes to scheduling. If you remember, when we are doing this, when I was trying to explain this architecture of Kubernetes, I talk about API server that is the one that accepts every request from the user interface. Maybe you are using the console or you are using the CLI. It's going to accept it. And once it accepts, it's going to authenticate it. So once you authenticate it, it's going to, maybe for example, the request is you want to create ports. So once you authenticate it, is going to instruct the scheduler to go and check which of the node. And okay, I can't remember if I mentioned this, but now, how does even this scheduler work? Now, if the way the scheduler work is, take for example, on these pods, you have, let's say you requested for, let me just use this as an example. Let's assume everything here is like, let's say 100 gig. Just, this is not related to you. I just want to use to explain. So maybe you can get this, everything here is 100 gig, but you have used like 70 gig. And this one too is 100 gig, but you have used like 30 gig. And what you are bringing here is 50 gig. The request is your limit 50 gig. So this scheduler will be like, if I put 50 gig here, this one is not going to, can't accept it too, because it's more. I have to put it here. So that's what the scheduler is going to find out, that where is it suitable to put this node, to do this, I mean, to put this pod rather. That's the work of the scheduler. So you want to schedule everything like event planner. Okay, let's plan it like this, let's do it like this. So it's going to return back to the API server, and API server is going to tell the which of it, maybe is this one, is going to instruct the kubelet. Okay, we want to put so pods on this node. So create the pod. So this kubelet will just create a pod and instruct this container runtime. That's why we are using what? Docker in this case. Remember I said in Openshift you use podman, and we have the CIO installed also in Openshift. So you use what? The pod, the container runtime will create the container inside the pod, go back to the API server, that okay, I've done this. API server will go to the etcd, put it in there in the storage, in the database rather, like that, if you remember. So now let's assume that we want to manually schedule our pod. You don't want this scheduler to what? To tell us where to put our pod. We want to put it in a particular node. Like this is the node that we want to put these pods, and we don't want this pod to be on this node. We want it to be on this node. So that is, and you know that normally this one does it automatically, like when you bring the request from the API server, it's okay, you want this size, you want this, you want this, you want, okay, this is a suitable one. But what you want is not this, you want it, I don't want anything scheduled here, you want it to be scheduled here. So let's assume you want to manually schedule your what? Your pods. That is where what? This is what we call the taints and toleration comes in. And taint and toleration is very, very useful when it comes to Kubernetes, because there will be some times that you want to use, for example, now you don't want to create pod on your master nodes. Let's say the controller plane, you don't want to create any pods on it. So technically that one is going to be tainted and you put toleration on it. Maybe the only thing that you want there is going to be the operators and the pods, the static pods that you want to use to create to create your nodes. So you put taint and toleration on it. So how does this taint and toleration works? Now, look at this. I wish I could get some diagrams to explain this. Look at this now. This is, let's say this is node 1. You put it on your nodes. This is node 1, node 2, node 3. So in this your node 1, you can see 1, 2, 3. If you taint this, let's say you taint this with red, you spray it with red. You taint this with yellow. You taint this with what? Blue. Now, if this pod is coming, these ones are tainted in different color. So this pod too will be tainted, is not tainted. Then we put something on it we call toleration. So let's forget about this. Let's go into the real life. Let's assume, like for use Nigeria for an example, we have something we call mosquito, and we have what? It causes malaria. So now, there is this body cream that they use in Nigeria that once you put it on your body, when mosquito is coming, you just smell it. It will what? it won't bite you. It will just go, or it can kill it. So it's a way to to prevent mosquito from biting. So that's a typical example of taint and toleration. So when you put that cream on your body, so if you rub that cream on your body, so what you will observe is that the mosquito will not bite you. But there are just some stubborn mosquito now, maybe say they are adapted to anything. So let's assume your skin is tainted with that cream. But they too, they can withstand that taint. Like, forget, I go bite you no matter how you taint your body, I go bite you. So they have the toleration to that taint. So now come back to this now. You tainted this node with red. Then the pod that is coming, you have to put a toleration on it, a red toleration. So when this pod is coming and it comes here, this pod will what? This node rather will what? We reject it. That means what? This one it doesn't have a toleration for this. If it is coming to yellow, this yellow too will bounce it back, like your body. When the mosquito is coming, it bounces back. But if it comes to this, because you have the word toleration to this, it will come on this node. You can create it on this node. But because it doesn't have toleration for this, it should not create on this node. Although this taint and toleration doesn't just work like this, there are many exemptions on it because there are other factors. So when we are doing taint and toleration and you are doing manual scheduling, there's many things you will still also consider aside taint and toleration. So there are still other factors that you're going to consider. I wish you are going to, maybe we are going to create we are going to use that. We are going to create a node. We are going to create, because you are using just a single node, and which is the Docker desktop. This is a single master and worker node. So we might not be able to do this now, but maybe in our next section, I will create a Kubernetes cluster on AWS with like 5 different nodes. And we're going to we have 2 masters and 2 workers. So if you do that, once we do that, we'll be able to do this. So we are going to explain this concept again. So that maybe that's what we're going to do in our next class. I'm not sure, but I think we could do that. We have different nodes, so we'll do the taint and toleration. So I hope you understand this principle. I don't know if you understand this. If you understand this, so let's just go to our documentation to show you more about this. Sorry. Sorry. Okay. Let me just do things. It's going to bring it up. Okay, so this is taint and toleration. Okay, after this, I will show you something I said I will show you before I've forgotten. So now look at this taint. So if I want to taint a node now, so this is what I'm going to say kubectl taint node, then the node name. Then I have to give it a key and value. So just like in our diagram, this is red. So coming back here, if we give it our key, that's not it. That was a mistake. So now let's say kubectl taint nodes. You don't want to taint our node. Then node 1, we want to give it a key and value. So now what is the key? It said the value. We have a key. Then let's say, for example, the diagram I show, we have red. Then we put it that no schedule. There are other, let me see. So we have what we call Okay, let me use, we have like 3, I think. Is it 3 or I'm not sure. Let me see the documentation. Okay, let me just, you see what I'm talking about. Okay, so okay, it's even here. We have no schedule. We have no execute. I think there are 3. I'm not sure the third one. So you want to put it like no schedule. That means don't schedule on this node. I don't know if you understand what I mean. Remember when I showed the diagram there, that I give you, this is the what's it called? This the taint and toleration. When I was explaining things, let me go back there. Like this is the red. We don't want to schedule anything on this except something that have the toleration. So if this one has the toleration, it's going to schedule on this node. But all this one cannot accept this because it doesn't have the toleration. So now the same thing. So but here we are still talking about taints. So when I taint the node, so this is what the command I give to it. This is the toleration. Let's say, okay, this is a toleration. I said this is the key. We give it the key, whatever I want the key to be. Then the operator equals to, which is this. What we are doing here is what we are interpreting here. So the value will be the value 1. So what do you want it to do? What effect do you want that thing to do? Is also no schedule. So this time no schedule, especially when we are still going together, when you want to drain a node. Next example, we have 3 nodes and you want to what? Update it, and you want to drain the node. You want everything that is that node to go to another node. When you drain it, everything there is going to go to another node. Then you put no schedule. The effect on it will be no schedule because the node has been drained. That you can't schedule anything on this node. Again, it's like it's under maintenance in that scenario. So now what we want to do, so this is different options. We have the no schedule. So this, the operator, let's say this exists. Operator here is equals to like what we have here. I'm trying to check for another. So this, remember, these are an API. This is a template to create a pod. So inside that pod, this is a label. Inside the spec, we give it a toleration. So here now we are what? Giving a toleration to what? To a pod. Just like in this diagram now, this pod now, we place a toleration on it. That the toleration, this is what you are going to do. So that's what we are trying to do here. This is the pod. We have created the pod. So in that the container, we said the toleration, this is the key. Put any key, what we want to do. As the operator exists, effect, don't schedule. That is what we do here. So you can do it based on anything that you want to do. You can see that this another effect here is no execute. So there are different ones that we can use. Let me check. I think there is another one. So okay, so let's go. So that's example of that is how we do. Well, that is what we do when it comes to taint and toleration. So I think maybe next section, then we are going to use an AWS cluster, create an AWS cluster. We are going to have like 5 different nodes. So in that, when we are doing that also, we are going to do installing and updating of clusters. So because we have different nodes, so that one will be easier for us to drain one node, update the version, because that also is very, very important when it comes to as a Kubernetes administrator. Be able to update your cluster, you must be able to schedule your nodes and code like that. So that is it on what? Taint and toleration. So I quickly want to run through another concept called the daemon set. So this daemon set is mostly one of the greatest application is when it comes to monitoring. It's very, very important. So what is a daemon set? A daemon set creates a replica of each pods on your nodes. So let me see. So he said a daemon set ensure that all nodes run a copy of the pods. Like you want to, each pods, a copy of it is created on each of the nodes. Like we have one of these, you must have one of these on each of them. Maybe you have 100 nodes, you must create each of that copy. One is just one of it on that what on each of the words on the node. Why and why is this important and where do we use this? It is used majorly when you want to do metrics, because Kubernetes does not come with its own metrics. So before you can, if you want to do a metric, if you want to install a metrics now on your nodes, then what you use is what you use a daemon set. So it's going to create each of these metrics on what on each of the nodes, and you have different metrics that you can use. So now creating a daemon set, this is a template to create a daemon set. You know, we are using a single node cluster here. So we might not be able to create this. And if you create it, you might not really see the importance and why it's being useful. So that's why I'm saying that we're going to do this when we are creating the cluster on AWS. So then we are going to have 2 masters and maybe 3 worker nodes. So from there now, we are going to do all this one, like the daemon set, the toleration, the taints, installing and updating our cluster. We're going to do it on that. That's where you're going to see the usefulness and why is it doing. But here now we are using just a single node cluster, which has the master and the worker together. So we can't really work on that now. But this is what the principle of the daemon set. So it's not something that is actually complicated. So once you create the templates, like just like the templates file here, give out the specification in which we are going to do. Like this is what is going to be running in the container. You see the volume one. So we're going to talk about this volume now and volume one. We're going to talk about everything now. So that's what I'm going to talk about now. This is the toleration we put on it. So we have different, this node, you can see here. Yeah, they are using different nodes to say, okay, maybe this control plane, this toleration we put on it, this is the other one. So that's how to create a daemon set. But just have it in mind that daemon set is to create a replica of a pod on each of the nodes. That's what the replica set is doing. And one of the main uses when you want to create your metrics, because if you want to create metrics, you have to create it on each of the nodes because it doesn't come with its own metrics. And how best can you do that? Using a daemon set. So that's how you do that. So now that will now lead me to what you know as, let me check our time. Okay, I think we still have like, let's say 30 minutes. Okay. Volume. So now we are moving now to storage. Okay, let me see. At storage. So under it, we have volume, persistence, storage class, and core. Let's check this. So we can see. So these are what we have. I want to show us what we have under storage. So if you look at documentation, we have what we call the volumes, persistent volumes, this projected volumes, or this one, there are other types of volumes here. We have the storage class, volume snapshot. This volume snapshot, creating snapshots is very important. So those are doing CK, it will definitely come out in your exam, creating snapshots. So we are going to go all through this. So we are starting with volumes. Now, from volume, volume is just, let's say, a space on a disk. How big is a disk? And when I think it's in part A, we talk about containers. The containers has their own storage, but it's what? It is in transit, that is ephemeral. Once the the container is what? Dies, then the storage dies with it. You can't have you don't have a storage with it again. So that has been a major concern that, okay, now something can happen, so container is just something that is temporary. You can just run a container, kill it, run it again in another pod as you want. So what will now happen to, maybe for example, you have a container for you have a container now that you create you create your database and you have collected some information is in it, and maybe something happens to the container and the container dies and it recreates, then that means all your storage have gone. And that's not what, it's not a good thing. So that's the area where we now come to the area of what? Volume, creating, there are many uses of volume. I'm just doing this generally and I'm going to talk about it. So when you create your persistent volume, then you can claim the volume. So now volume here, you can do you have different volume types. In AWS, we have the Elastic Block Store. We have the EBS, which is we have a lot of them. In this one are in AWS, in Azure, we have in Google Cloud. We have, so there's another thing we call the Ceph. This Ceph is a most used volume type now. And this Ceph is common when it comes to Openshift. We use more of Ceph volume in Ceph. So most of the Openshift cluster that I've installed, I use more of Ceph to install them, and they are mainly installed on bare metals. So now volume, so you can do a lot of things with volume. You can use volume to mount your secrets. So you're going to get to secrets, I'm going to get to config map very soon. So it's like, okay, we have an hard disk now. Let's just go back to our computer now. Let me explain the concept so you're able to get it. Let's go to back to our computer. So in our computer, maybe you have your desktop, you have let's say 500 gigs. And let's say 100 gig. Let's say 500 gig, right? Okay. So if you create a folder that worth 20 gig and you put a file inside of it, it will still be what? It will take part of that 100 gig. Is it 100 gig or 500 gig that you have on your hard disk, right? And it's still what? On that hard disk. So the same thing with this. If you mount a config map on your what? On your, you can mount a config map or a secret. We're going to go to what config map is, a secret data. So you're able to, I'm just using this as a general, it's just a general overview. So we are going to mount it as a volume. So we are going to, like, you are mounting a secret to your storage as like a volume. And this is the let me use the best way in which you mount your secrets, you mount your config map when it comes to in your cluster rather. So this is the best way in which you mount your secrets. You mount your volume config map is use of volume. So we are still going to get there. I'm just trying to tell us different, just give us general overview. Then we start with persistent volume. So all this. So now let's now go to what is called persistent volume. So now what is it that we call persistent volume? So if you are familiar with Linux, you know what persistent volume is. But if you're not familiar with Linux, then persistent volume is when from the word name, from its name, persistent, like you want something to what? To stand, to be continuous, persistent. So you know that container storage and volume is ephemeral, is in transit, it can just die at any time. It's not permanent, it's temporary. But you want what? A storage that will be permanent. That even when this container dies, you still want to have your storage. That's just a simple extension of persistent volume. So you want to create this volume, and if even if the container dies, there's a location in which you can get back all everything that is being stored in that container. That is why we say we want to make I want to make it persistent. You want to create a persistent volume. And note something, as a Kubernetes administrator, you are the only one that have the permission right to create persistent volume. So you are the only one that have the right to update the cluster. So let's assume someone that is writing CKA, you can create persistent volume. But as a developer, let's say like Kubernetes application developer, they don't create persistent volume. They don't have enough access to create persistent volume. So what they do is what? To create persistent volume claim, to claim from that volume that has been created. So I'm still going to get there. So now let me show us a diagram to explain this. So I hope you can see this well. Let me increase it. So now this is storage now. This is the admin, this is the Kubernetes administrator. It will create a pool of persistent volumes, and it's going to give it a location where it should be stored. And definitely it's not going to be on the container. It has a particular location that the information will also be, like the information will be stored. So you can create several persistent volumes as you like, P1, P2, P3, the PN. So as a developer, so this person now, let's assume this is the CKAD, which is the developer. For it to be able to make everything that he created, maybe he creates the pod and the application that he or she creates in that cluster, he wants it to what? To be stored in that volume that has been created. You have to claim this volume by creating what we call the persistent volume claim. So whenever you create a persistent volume claim, it's just like we want to how will I explain this? We want to bind something together, like, okay, a volume has been created, but we want to claim that volume, that, okay, we want to connect to that volume. So we'll be using that volume. So if someone like this developer creates this claim and bound to this, you see that it has been bound. Someone else cannot bound to this volume again. Like this volume has been reserved for this claim. You can create another claim to bound with another volume like that. So I'm going to do this in our code now. So just explain the principle. And there's something also called the storage class, in which should we go there now? Or okay, I think I will explain that soon. So now when you are creating your persistent volume, like there are ways of giving maybe provisioned. You can create it statically or dynamic. It can be dynamic. So when it comes to static, that is when the what's it called? The administrator creates a number of persistent volume. So if you create a number of persistent volume, then you have to put the detail in the storage, in the real storage that, okay, this is the persistent volume. Then you don't really need to create any claim because it is static. So this is just the volume. So you can just connect with it. But dynamic, okay, yeah. So in static, you also create claim. That is when you can claim it. But when it comes to dynamic, that is when you use of storage class. That you have created a storage class. And when you are creating a storage class, and that is where what we call the operators. I don't know if you are talking about operators. It's very important. There are what we call operators in Kubernetes and in Openshift. So operators are what makes creation of the cluster easy. So the operators in this sense create the storage class in which is going to be automatic. We are going to, okay, let's just take it one after the other so I won't just rush us with everything. So once the volume has been created, you can bind to the volume and it will be bound. So now we are going to create one. We're going to do an example and see. So this is how you create your persistent volume claim. And this is how you create your persistent volume. You can see here we have a storage class. Here we are not using a storage class yet, so I'm still going to explain that. So if you go down, like I said, we have different types of storage. We have the self, we have a lot. So now let's use a template here. This is a persistence. We're creating a pod. Let's use a template. So, okay, you can use this too. I'm coming. Okay, I think. So from here, you can easily know what you are. You can look at it, this persistent volume claim. That's why we are going to differentiate them. Looking at this is a persistent volume claim, this is a persistent volume claim, and this is a pod. So this is creating a persistent volume. So now, before we do this, let's go back to our command line and see, do we even have any persistent volume? Get PV, that's persistent volume. So here, we have one persistent volume, which is at default. You can see it here. It's a default claim. And you see something here is bond. And we have what we call the reclaim. Okay, let me even explain this was like this. So let me use this template to explain to us first before we go to the command line and see what we are creating. So remember, talk about 4 things is very important. We have the API version, we have the kind, metadata, and the spec. API v1, which we know how to get that. Kind, persistent volume. So the metadata now, that's where it's contains the information about what we are creating. This is the name. Maybe we want to put a namespace. You can put the namespace, label, and co. Everything will be under the metadata. Then the spec. So now, when consuming this spec, these are the things you note. Look at the capacity of this volume. You say this is a 10 GI. This is not gigabytes. So 10 G is 10 gig. So 10 GI is giga. Let me do it. Let's do something like so. Why is it? Okay, let me do something like this. GI storage. So you see definition of different terms. I was expecting it. Okay, am I connecting to? We have different storage class. That's where I want to go. So this is the def. I'm looking for one. We have GIB, we have GB, gigabytes, like just showing the storage capacity. So 1 GI equals to 2 raised to power 30, which is something like this in bytes. Just want to show the memory resources. I explain everything. If I can get one here, I'm not sure, but let's just see. Continue reading, still loading though. Okay. So like this is megabyte, this is kilobytes, this is gigabytes, terabytes, exabytes. There are lots. Okay, like okay, now yeah, we have GI. Gigabytes. Sorry, I don't want to pronounce it earlier, so that won't just eat my. So yeah, we have this different definition. We have this kibibytes, we have the megabytes, we have the gigabytes, we have the terabytes. So if you see this, you know what they are representing there. So that's what I just want to show us. Okay, let's go back to. So that is 10 GI. Is know the meaning of this now. Now we want to see the access mode. We have different access mode. We have 3, I think. We have the read-write ones. Read-write, always, so I've forgotten. We have the RXO, RWO. Let me check if it is here in the document. Okay, I think it should be somewhere here. I want to be sure. Okay. So we have the read-write ones. We have the read-write. Yeah, I can't remember honestly, but I think it's in the documentation, so it's something we can just get. So you don't really need to put it. Just you don't really need to memorize it. Okay, yeah, this is what I'm looking for. There are 4. So we have the read-write ones. We have the read-only many. That's ROS. We have the read-write many. You have the read write once pod. So these are the types that we have, and this is the definition. So if it is read write once, what is saying that the volume can be mounted as read and write. You can read and write on this storage. And it's just a single node that have access to this. That's what it's saying. So like you want to access it to a particular node, and there's only a single node that can read and write on this, but different pods inside these nodes can access this storage. That's this. Then read only many, the volume can be mounted as read only by many nodes. So many nodes can have this volume, but you can only read from this storage. You can't write to it. That is what that one is telling us. Maybe that's what we want. Then we have read write many. So the volume can be mounted as read write by many nodes. So different nodes, many nodes can write to this and can read from this. So the same thing, they have the read write once pod. The pod can be mounted as read write by a single pod. It's just this one is just attached to a single pod. That's how that is. So once you just go, that's why documentation is very important. Go to access mode. So why is it like this? So let's go back to this. Not the one we are using before, but we can still use this. It's still the same. So another thing is volume mode. So if you look at, there are many volume mode. Remember, we talk about, let me show us again. So, but just don't be bothered about me showing you all over and over again. I just want us to understand the principle and why we are using it. So if you understand the principle, the command and others is just what's it called? It's just a small thing, but you understanding the principle is the main thing. Is it here? Okay, it's not here. Okay, so it's just like the mode of the volume. Is it file system? We have other nodes too. I can't really record them. So that's what this one is saying. Might decide to put the volume mode there or not there. So you understand this access mode while we are using this write ones. You can use another access mode. So now we have what we call the persistent volume claim policy. So now we have three of them. We have the recycle, we have the retain, and I think we have another. Okay, sorry. Let's check again to be sure. So I won't. Okay, yeah, three. Okay, yeah. We have the retain. So that means if you should delete this, you can retain, you can just retain it so someone else can claim it. So we have the recycle. Once it's deleted or it's being removed, you can recycle that volume, and you have one that once you delete, is gone. Those are the reclaim policy. I want to quickly rush over so you can have time to do an example. So that is it. So this is storage class name. I've not talked about storage class. Then we talked about the mount option. Let's just go to the command line and get this. So now looking at this is the storage class name. This is what the capacity, like we saw then. Then this is that first mode. You see read write only. I mean read write once, I think. Is it? Read write once, yes. This is the read write once. Then status bound. Why is it bound? Because it has been claimed. That is why it is bound and it is a default one. So now, so let's just create our own. Let's see if we can create it with the help command. So when you duplicate create help, so we can create from here. So we can create a template from here. So that means we have to use what? We have to use our documentation, the template from the documentation to create one. So let's create this and see. So control vi pv.yaml file. So if you have any question, you can just bring it up. So now we want to create a persistent volume. So now let's start with the name. Let's say PV1. Then, because we want to create everything we are doing in our namespace that we created, let's use that namespace. What is it? Part 3, right? That's the namespace we are using. So this is spec. Let's give it storage of 5 gig. Okay, let's do this. Let's do, because we are using one node, we can use this access. You can use this. So we don't have a storage class. So let's just remove this. So let's remove all this. Okay. So now let's create this. Create FPV. So no file expected key. So let's go PV1. So what's the issue here? So can someone tell me? Does someone know the mistake we had here? We have here. Anybody? Okay. So the issue here is this namespace is not aligned. So indentation. Requires volume type. Okay. We remove the volume type as in the beginning. So you see that it's different error that is giving us. So we remove the volume type. Let's put it back. Let's go back to our documentation. Storage, where is the volume type? We removed. Let me check again to be sure. Spec, there is no. Let me check again from documentation. Which one do we remove? This is storage name class. Okay, let me return it. Okay. So let's check again. Storage class. Okay. But this gives us an error then. Volume type. Okay, wait, the persistent volume PI is invalid. Spec, okay, required value must specify volume type. Okay, I know what the issue is. Under our spec, assessment recycle. So this month's option, we don't know where it's going. Oh, okay, okay. So let me use this. Okay, I'm not using NSF. Okay, let's go to this. Okay, I know what it's saying. This pod. Okay. Oh, so this is what I was saying. So we have file system, we have block. So like what I was trying to remember then, the volume type. Let me see if I have another one. Just a moment. Okay, I don't think there's another template. Okay, so let me use this template. This is the one I used earlier. Just a moment. It's always down here. Okay. Let me use this. Okay, so let me just switch this. Write it back. And okay. Volume name and PV1. Name the namespace. We are in part 3. Okay. This is spec. Let's do 10 gig. Let's leave it like this. Okay. Oh. volume type. Why am I getting it wrong? Okay, let me put in a volume type here. Let me check. Claim name. So now I can do something. Okay, get PV in YAML file. So what I'm trying to do is I want to get the template of the created PV. So I should put the host path. Okay, which host path can we use? Okay, so now let's do this. Let me do pv2.yaml file vi pv2.yaml. Okay, so now let's remove everything that we don't need. So let's do pv1. Just so now we are trying to let me do that annotation. Claim ref. So now this one is static. You can see the claim ref. You have already shown what is going to what is going to claim it. So so let me just remove all the claim ref. So I should have a host path. Should I leave this? Okay. I don't need the type. Let me just use it. Storage, host path, file system. Okay. Okay. Let's try and create this and see if I don't need this. I don't need this. I'm sensing we are still going to get an error. I know what's going to happen. Create F. So if you want us, we can put this to neglect the error, but we still have kind not set. Okay. Oh, okay. API. Okay, this is what happened. Let's remove this. Okay. Okay. So this is what happened there. In that previous one, we created, because we create a static one in which we put the one that is going to claim it. I will show us here. In YAML before we direct it. Okay, so this is the default one before we direct. Let me quickly show us what is there. This is the API. So we create inside the API version, we listed this one to be the persistent volume. So we created another one down, which is, okay, this is a persistent volume. Then we create, inside it, we create our API again. That's the persistent volume claim. Now we already want this one to claim this volume. So we already created it together. That's static. So that's what happened in what we created initially. I mean, in the template I copied. So, but look at our own template. We create a persistent volume, which is PV1. This is the annotation. So we give it an host path. So like, this is the host path that we want it to be. So this volume should be in this path. So everything that is there should be stored in this is the path that I want it to be stored. So, and this is just leave this type there. It's nothing there. This is the persistent. So we want to delete. Oh, we shouldn't use anyone. We can use anyone just for example. This is storage class name. We just use the host path, which is this one that we have created in our annotation. Because we are using a single node cluster, that's why we get it like that. And then this is the volume, the file system. We'll soon be rounding up now. So just showing us our template file. So now let's get our PV. Oh, sorry, I made a mistake. Sorry. Remember we said our persistent volume doesn't have a namespace. So I put a namespace. Yeah, it shouldn't be there. Yeah, okay. Get PV. We are still going to see it here because we said it's not namespace what bound. So let's just go there and correct that. I just remembered. Okay, we didn't even put the namespace. Okay, it was in our, okay, I think that was why we were getting an error when we put the namespace. So we shouldn't put a namespace here because it's not namespace bound. Yeah, okay, I think this is correct. My bad. So you can see it's here. These are persistent volume. But if you should look at it here, it is what? Available. Why? Because it has not yet been bound. We just create the volume which is available. Just like in this diagram, we create this PV. It's still, yeah, it's not yet what? It's not yet bound. So now, how can we going to bound this PV now? Let's create a PVC. So from our documentation, you can see where we can create our PVC. Look at this persistent volume claim. So okay, we can use this. We can use this. I just want to use a simple one for us. Let's just copy. So the most important thing here we're going to see so let's create another one, PVC 1.yaml. So now look at this, our API PVC methods. So what's the name of our PVC? Let's just give it a name. Part 3 PVC. So now, because it's PVC, we can claim it in the namespace. Part 3. That's the namespace that we want to use it. So now the storage class name, I can't remember the storage class name we use. I think it's host path. Without that, it will not. So this is the access mode we created then. I'm not sure if that's the storage class name, but you can always check. So let me check again. This storage class name. Okay, it's host path. So now let's create our PVC. If you have any question, just bring it up. Okay, create F require valued storage. So now what storage do we use? Yeah, because we didn't include the storage capacity. Okay, so now let's go to our documentation volume mode. Okay, let me use this one. Let me bring the storage, copy the storage from here. We use the storage class name, access mode. So the storage is 10 gig, no, 10 or 3 gig. Just a moment. So let me confirm that here. Storage file name. The version is this hotspot storage persistent policy. Okay, storage hotspots and this file system. I think that's what we use. Let me check our PV again. Okay. Okay. And the storage is 3 gig. Okay. So now if they don't rhyme, it won't bound to themselves, it won't even create. That's why it's giving us that error. Sorry, so I have to do it like this for indentation. Okay. Are you with me?
Yes. Yes.
Okay. I hope we have this indentation correctly. Let me check again. Yep. Let's create it and see. Oh, no. So now what is saying to us now? Unknown field persistent volume claim policy. So we are not going to ignore it. Let's go back. So yeah, what it's trying to tell us here is persistent volume claim.spec. You can see that it's showing us to that place that we have the issue.spec. Unknown field, that's persistent volume claim policy. So that means it shouldn't be, where's this? It shouldn't be here. It's okay, I just copied it there. So even this, okay, let's just create what we want to create. Was storage, okay. So let me check the storage we're using. One storage class name is host paths, which, oh, sorry, not this. Oh, okay, I have two of them written. Okay,
You have it right. You have it right.
yeah, that's the reason. And it should, okay, I think it should not be on access. Okay, it's not an access mode. Okay, I think I wrote it twice. The way I just copied it down. Storage, didn't it? Okay, okay. Now I know, because, when we did our persistent volume, we put the storage that we want. If you remember, let's go back there. We said it is 3 gig. So the thing is now telling me that it's created 3 gig. Is it 3 gig that we created? What storage do you want? What's the capacity of what you want out of the volume? So that's why it's telling that the storage is not specified. So how do we include the storage here? Let's use our persistent volume claim, access mode, resources request storage, 10 gig. Of course, we'll go and change it to 3 gig, because if you say 10 gig, it will tell me that, okay, you want 10 gig, but it creates 3 gig. Okay. Okay. No, not 3 gig, 3 GI, sorry. It's So now it's created, but what happened, what we are trying to do is, I've forgotten to tell it that, okay, is the thing is telling me that I know you are trying to create this storage, you are trying to claim this storage, but what is the capacity you are claiming? Because I created 3 GI. That's not asking me what storage do you put. So I forgot to put the storage there. So that's it. So why this is done now, let's get our PVC, that's persistent volume claim. Do you see that this is our persistent volume claim? Is it this? This one is what? Pending. This is not the one we created. You know, it's part 3. Why are we not getting it now? Can someone tell me? Anybody? This one has been created like 103 days ago. So it's not this. And this one is still what? You see that it's pending. That means the volume is there, but not bounded yet. Can somebody tell me? Because we create it in another namespace. So this is the one we created now, part 3 PVC. Is in this namespace that we are using 68 seconds ago. And you can see that the status is what? Bounded. So if you should look at K get PV, this one, you will see that is bound. They are now bound. So that means the volume has been attached to that. So what's our time? So the next thing now is to what? Can we just, okay, let's just do that. K get pods. In our, what is it called? In our part 3, I think we create a pod here. So we want this pod to use that volume. So if we describe now, okay, describe pods in part 3, because it is one pod, we don't need to put the name. So if you should look at it, these are defaults. It's telling us about the pod. This is the pod we created, blah, 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 blah. This is the label. But now what we want to do is, let's just use this pod that we have created. We want to now mount that volume on this pod using what? Volume mount. Using volume rather. We want to mount that storage on this pod. How are we going to do that? So now that's easy. Just go to documentation. Look at this. Now this pod that is created. Now this is how they mount it. So now I can just go back to my volume here and still edit pods in my part 3, because it is one, it's going to edit this pod for me. So this is the pod. Now I want to mount this volume on it. I come to spec. You see that this is where it is. This is a default mount that is on it. Because once you do it, it created a default one for us. And this is the default one. But we want to create our own now. So let's add this. Let me come here. Escape. So just that you might have var. Okay, might just put it in dash var. Okay, so okay, I've messed this. Okay, let me do something like this. So let me direct it to a YAML file so we can easily remove it. Volume. That's YAML. Okay. Oh, sorry. Oh, come on, I've messed this up. Okay. So I have to create a new. Let me just do this. What am I trying to? Okay. Let me go back here. Let me just copy it. So what I should do is K get ports in part 3, right? I want to get it in YAML file. This is it. Right. So let me now redirect it to volume.yaml. Then volume.yaml. Okay. So we now open this. So let's just remove this like this. So let's leave our DNS policy there and then let's do let's copy this month and the name. If you have questions, just let me know. So let's change this to .var. Might not use this. So let's do what's the name of our pod. Let's use my part 3. So we have created a volume month. So now let's now create the volume on its own. This is the volume. So this is the volume that we are creating on it. Oh, what's this? What did I just copy now? Okay. Okay, let's do volumes rather. I'm going to edit that now. Volumes. So just where are we? Volumes, okay. What volume are we using? We are using a persistent volume claim. Remember, we created a persistent volume claim. So what's our claim name? Oh, can someone remind me of our claim name? Do you remember? Okay, let me check it here. What's our claim name? Okay. This is our claim name. Oh, come on. So we'll be done. Let's just, so this is our claim name. No, this one is not necessary. Let's just remove this. Service account, so this one not necessary. So this one is just putting its defaults. Let's remove all this one. this. Okay, we're almost done. So okay, so just like you want to apply this pod again. This is the namespace. This is the nginx. Don't need this. Volume months. Okay. So just note that this must be the same with this. The name of the volume must be the same with our volume months here. So my part 3, then persistent volume claim. Then this should be under the claim. I think this should be like this, the claim name. DNS policy cluster for this one, just telling about the DNS policy that we are using. It's not necessary though. And service account, we start policy. Okay, so I think this looks good. So the next thing we are going to do is we are going to replace a minute. Okay, we are going to replace this pod because we have created it already. So okay, replace force-f. So it will delete the first one. It will create the second one. So okay, get pods in our part 3. Oh, what happened? We did cache looks off. Okay, okay. Describe pods in our part 3. So what's the issue with it? So there's something we did wrong there. Status showing submitted error. Why? Okay. Started container. So let's do klogs. So klogs in what? Part 3. Let's do the log. What do we do? Klogs, what's the name of our porch? Port 3. So these are all the logs that we have. Attempt to perform configuration. Ready for startup. Could not open error file. No such file as this. Oh, okay. So so if you look at this, the main reason here is because of this part, this month part that I give to it. And I'm trying to check something. What if I use the same month part? Okay. Okay. Do something now. Okay. Image. I'm trying to troubleshoot what's wrong. Should be able to monitor our volume on it. What's our time? Oh, our time is fast spent, but let's just quickly go through this. Let me see where is this coming from. Oh, let me get a log second. Conclusion. Okay. So one of this is the part I gave to it. I didn't create that part on my local machine. I know it should be /var is there. /var is there. So let me do something here. Okay, let's put in part 3 namespace. Voila. It should recreate. Let me see if it's even recreating. Let's watch it and see. I think the issue also will come from the issue because I'm using a Docker desktop. It has its own mount path. It has its own mount path. So, and it is, it's a single node cluster, which is the master and the worker. So that's one of the issues. This thing is not recreating. Why is it taking this to recreate? Okay. Okay, I'll be done now. So just on the final notes. Okay. Let's just policy, maybe policy. Remove this. Resources. So the main issue I'm saying is this month path. That's here. I think everything really looks good here. Everything looks good. So the issue is going to be with our month path. Let me just replace this pod and see. There's no issue with our template part, but what I'm checking is the month part. But I think it's created another month part with a Docker desktop. So that's what is happening. Cache loops up. Let me get the pods logs again. So is this part that is giving me the issue now? No search file in the directory. It's not able to create that part on the engine. So what I can do now is I can just go and use these parts. I can use this month parts. Let me check the volume month. So that should work. Okay. So let me check the volume month it's used. So if I use this, it will work. Let's see. I can as well create that, but Let me just use this. So can you see that it's working now? So the issue I have with is the path. So now what I did now is I went to use this path that was created that is in the Kaka desktop. I can actually create that path, but I just went to use the path directly. So when I use the path directly, I got it. So this is the mount path because we want to mount it on something. We want to mount it in a particular in a particular story. That's where we want to mount it so that when everything goes down, we can easily access that and see. So, but the one I gave does not exist at initial. So that's why we have the what? The error. So now let's look at our pod. It's in running state. Let's check the logs. You can see that we don't have the logs that we have before. So this is how we're going to mount what we want to mount our storage on our pod. You create a persistent volume, we bound it, then we mount it on our pod. So I think in this note, we're going to end this section. So we'll continue our section tomorrow, where we'll be talking more about persistent volume and claim, talk about secret and config map. And that's, let me pause recording. If you have any question,